Welcome to the Explainer. Today, we're going to jump right in. Think about the biggest, most absolute showstopper for humans ever living on Mars. It's the air we breathe, right? Well, what if the solution isn't some giant, complex machine, but something tiny, like microscopically small? So, here's where we're headed. First, we'll tackle that huge breathing problem on Mars. Then, we'll meet this unlikely little hero that might just be the answer. We'll see how it survived a brutal Martian test. And finally, we'll get into the big picture, what this all means for us actually living on other planets. Okay, first things first. Let's really dig into the core of the problem here. Maybe the biggest single thing stopping us from setting up shop on Mars for good. We all dream about living on Mars, right? But it really boils down to this one question. Forget the fancy rockets, the cool habitats, just for a second. How are you supposed to breathe? It's the most basic, constant thing we need, and we'd be millions and millions of miles from a planet that's full of air. Look, if we're serious about a real colony on Mars, we can't be tethered to Earth like that. It's just not going to work. Imagine shipping tanks of oxygen. Every single one has to survive a 9-month trip through space. The cost is insane, and it's incredibly risky. No, that's not sustainable. The only real way is to learn how to live off the Martian land itself. So, if we can't pack our own air, what's the move? Well, the answer comes from a place you probably would not expect. To crack this, scientists turn their attention to some of the absolute toughest life forms right here on Earth. They're called extremophiles, and they're basically these microscopic creatures that love living in places that would kill pretty much everything else. We're talking boiling hot volcanic vents, the freezing abyss of Antarctica, you name it. They are, without a doubt, nature's ultimate survivors. And that brings us to our little hero. It's a type of cyanobacteria called, get ready for it, crococodeopsis. Yeah, I know, it's a mouthful. But this tiny organism does something incredible. Just like a plant, it uses photosynthesis. It breathes in carbon dioxide and breathes out oxygen we can actually use. And the crazy part? It can do this in some of the most brutal environments you can think of. Okay, so we've got our potential hero, right? But how do we really know it has what it takes to handle Mars? Well, let's dive into the super clever way scientists decided to test it, by basically creating a mini Mars right here on Earth. The whole experiment was beautifully simple, really. Step 1, they made a special soil that's just like Martian regolith. You know, that dusty, super nutrient-poor dirt that covers the planet. Step 2, they dropped in our little microbe. And step 3, they just watched. That's it. The big questions were, would it even survive? And maybe even more important, would it actually do its oxygen-making job? And the results? Whoa, they were absolutely amazing. This little guy didn't just hang on for dear life, it actually thrived. It was pulling what little nutrients it needed from that fake Mars dirt. It was shrugging off intense radiation, and get this, it could even repair its own DNA when it got damaged. And through it all, it was just steadily churning out pure, breathable oxygen. So this isn't just some cool lab experiment to read about. No, this is a total game changer. It has the potential to completely flip the script on how we even think about setting up a life on another planet. And it all leads to this incredibly powerful idea. What if, instead of shipping air across the solar system, we could just farm it right there on Mars? We'd go from being these dependent interstellar importers to being totally self-sufficient, Martian oxygen farmers. How cool is that? I mean, just look at the difference. Shipping it from Earth, super expensive, super risky, and you just can't keep doing it forever. But making our own oxygen on site with these little microbes, that completely changes the game. Suddenly it's renewable, it's way less risky, and it's a whole lot cheaper. And you know, this is bigger than just oxygen. A living system like this is a critical piece of the puzzle for creating what's called a closed-loop life support system. That's the whole shebang. Recycling air, water, everything you need right there on site. Any long-term Mars base is going to need that to have any chance of succeeding. So yeah, this is a huge step, a massive leap, really. But we're not quite at the finish line yet. Let's take a second to look at the next set of hurdles and some of the even bigger questions this whole thing brings up. The lab results are one thing, and they're fantastic, but now the really tough engineering problems start. I mean, how do you go from a tiny petri dish to a system big enough to provide air for a whole crew? And how do you build a bioreactors that will house and protect these little lifesavers from Mars's crazy, unpredictable environment? But let's step back from the Mars mission for a second. This whole discovery points to something, deeper. It's about how incredibly tough life is. It's just this amazing reminder that life is unbelievably adaptable. It finds a way to survive in the absolute harshest places we can even think of. And that really leaves us with one last big thought to chew on. If a tiny, simple microbe from our own planet already has what it takes to make a go of it on Mars, what does that tell you about the rest of the universe? If life really is this tough, this resilient, where else could it be hiding right now, just waiting for us to find it?